So this is the solution to problem number 1B, number 3 in the set 1 in this second level, and this is the third problem. So in this problem, you and your teammates have two possible designs for your balloon rocket, and you're debating which one to choose. So you want to write a brief recommendation for the next day so that you can recommend to your team which one's best. You have the following data. Alright, the first design has a mass of 0.25 kilograms, a fourth of a kilogram, including all the payload, those 4 pennies, for example. Because the balloon is inflated more fully, it can provide more thrust, so it can give us some more force. Drag forces on it are about 1 Newton. Alright, so when we tabulate that, we get this. The mass, we're going to label it number 1 since it's the first design. The thrust and the drag on it. And we're looking for the acceleration. And the reason we're looking for the acceleration, we're trying to figure out which one's the best design. So there's a couple of conditions we sought out to make it what's the best. In this case, best is the same as the highest acceleration. Alright? With the high acceleration, you can get further, faster. In order to work best, the rocket must accelerate the most. This will mean more distance in less time, as I wrote here. So this is explaining your strategy. This is why we're doing this. We're going to figure out how to connect these to this. And so we have our two equations. All right, the F net, the force, all the forces added together, and Newton's second law. With these two equations, we have enough information and enough equations to solve for the variable. All right, so we look at both equations, we look at what we have, and we realize that we don't have the net force, we don't have the acceleration, so we can't do this one first. We got to figure out one of these things first. All right, so we look back at this. What else do we have? All right, so we need to add these two forces together to figure out what the total force is. So that'll be our other equation, and we'll use that one first. So we plug in these numbers, and these cancels out. This note is negative because it's drag. And we already said that the thrust was positive, so that must be the opposite. So we have to think about that. It's not given to us. It's given to us in the word rather than, given to us as a number with a negative sign. So we have to think about that. We throw that in, do the math.